So welcome everyone to Strait Science. Strait Science is an evening science presentation series put on by UAF, Northwest Campus, right here, and UAF, University of Alaska Fairbanks, Alaska Sea Grant, also here in Nome. And Strait Science, Alaska Sea Grant, and Northwest Campus, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik. So for tonight's speaker, we have in person, so bear with us with the new system. We have in person Elizabeth Siddon. She goes by Ebett. She is with the NOAA Alaska Fisheries Science Center that is actually in Alaska. We hear a lot from the Alaska Fisheries Science Center that's in Seattle, but actually Ebett is coming to us. She has flown up from Juneau. She's here in Nome, enjoying our Nome situation. And she is a NOAA fisheries biologist, and she is the ecosystem-based fisheries management lead at the Auke Bay Labs in Juneau, which is that Alaska Fisheries Science Center in Alaska. So tonight, she's going to make sense. We get a lot of survey work that's done. We get a lot of NOAA and others doing work, and she and others compile the information from all of that research into ecosystem status reports on an annual level. And I believe this is the first time we actually have someone talking to us tonight about NOAA's ecosystem status reports. So I'm going to turn it over to Ebett and take it away. We're so glad you're here.
All right, thank you. All right, hi everyone. Thank you for joining us. I'm going to shrink you for now on here.
And we do, just to interrupt for 1 sec, we do have a caller. So callers are a priority. If you have a question, just unmask yourself and ask it. Or you can call my phone, 907-434-1149. Callers get priority. Thank you.
All right, great. Well, thanks everyone. I'll jump in. Maybe if I can get there we go. But before I start with the slides that I put together for tonight, I just wanted to take a minute and say thank you to Gay and the university for the invitation to come and to give us Strait Science, and to all the community members and folks that I've crossed paths with in my last couple of days here. It's just been a real treat to be able to come and be here in person, and I'm really grateful for the opportunity. So thank you for the invitation. So I do have some slides, but I also am interested in making sure that what we talk about tonight is of interest. So don't hesitate to raise your hand or interrupt and ask questions as we go, because I'd much rather talk about what you want to hear about. So don't worry about interrupting me. So these are sorts of the topics that I thought I'd cover. What are the ecosystem status reports and how are they used? And then I'll go over the 2023 ecosystem assessment. I've broken it out this year into the Southeastern Bering Sea and the Northern Bering Sea as sort of two separate summaries. This is information that I presented to the Fisheries Management Council in December. And then I have just a couple slides on what we call our risk tables. These are for individual species that we manage in the Bering Sea region. So I'll talk just a little bit about what they are and how they're used in setting quotas for fisheries. And then a couple slides on sort of where we're headed, looking ahead at 2024. Can you see hands, Gay, if somebody?
Yes, if somebody has something in the chat, we'll
you
grab
can
it.
see it. Okay, because I can't see it from here.
And I can see that someone's trying to get in. So
okay.
All good.
Okay. All right. So first, NOAA provides the science to the council. That is the body that makes the decisions about federal fisheries management quotas. We provide them the science to help them think about how to balance these different competing interests for the resources in our oceans. So these are just some examples of things that use the fish in our ecosystem, and we talk about how to balance those different needs.
Who's the council?
The council,
Oh,
the
right.
North Pacific Fisheries Management Council, is the management body for all of our federal fisheries in the North Pacific. There are regional management councils around the US. The North Pacific is ours for Alaskan waters, and the white outline in that map there is the outline of our, what we call large marine ecosystems, and where within these large marine ecosystems, we manage our fisheries. The council itself meets 5 times a year for close to 10 days a pop. So there's a lot of talk about fisheries management in Alaska. They set catch limits annually. So each of our stocks has a review at some level every year, looking at both groundfish and crab. We, within NOAA and within the council, talk a lot about this term ecosystem-based fisheries management. This is a way to look at, instead of looking just at any one species in isolation, to look at everything that's happening around that species in an ecosystem. How is its habitat? How is its prey? How are its predators? And then also think about the quota. How many do we think we can sustainably remove next year? So there's a variety of different tools that we have within the system that are ecosystem-based fisheries management tools. I'm only today mostly focused on the ecosystem status reports as one of those tools, but we have in the lower left some different sort of big projects, climate-informed ecosystem modeling projects that are happening across different Alaskan or different large marine ecosystems. The ecosystem and socioeconomic profiles that are being developed for each of our different stocks or fisheries. Things like optimum yield caps in the Bering Sea. There's a 2 million metric ton cap of groundfish removals every year. Different time and area closures to protect certain species at maybe different times of life. And then protected species catch limits, things like bycatch for different species. So all of these things help us think about the health of the ecosystem and how the ecosystem might be impacting different species. And this is sort of a graphic of the flow of information through the system. So if I were to start on the right-hand side and read this page backwards, on the right-hand side, there is this huge sort of machine generating of knowledge and research. There's so many people interested in working in the Bering Sea and in Alaskan waters, and they're studying different aspects of it. And when that research comes to a point where it's ready to sort of come over to the left-hand side of the screen and be ready to be thought about in a management context, then it might come through the ecosystem status report or the ecosystem and socioeconomic profiles or the stock assessment, and then it can inform the council decision. So these different hexagons, honeycombs on the right are just some examples of kinds of things we do, things I thought might be of interest to the region: harmful algal bloom work, sea ice changes in sea ice abundance, thinking about things like fish condition. How are they doing in terms of not just the abundance of them, but the health of them, the sort of fatness, or are they skinny because they're not finding enough food? I mentioned earlier that we look at these stocks every year on an annual setting. So this is on the left-hand side. Each stock has a stock assessment model. A whole bunch of data dumps into that stock assessment model. It can come from research survey data, some of the groundfish bottom trawl survey, ecosystem data, fishery data, goes into this assessment model, and that model spits out what we call the maximum acceptable biological catch. That's the max that the stock assessment author thinks is sustainable to remove from the population in the following year. And then that stock assessment model recommendation goes through all these different arrows, different levels of review, until finally the Fisheries Management Council sets the total allowable catch. That total allowable catch could be set at the maximum catch that the stock assessment author recommended, or could be lower for a variety of reasons, can't be higher. So the ecosystem status reports come into the process at each of these different steps, because we provide, through the ecosystem status reports, this contextual information of what's going on in our region and in our ecosystems. So we can inform things like whether we're in a marine heat wave, or whether we don't think there's been good food, or maybe there has been good food this year. And so we can have these sort of different on-ramps and ways to inform the decision makers before they set that final total allowable catch. For the ecosystem status reports, we're sort of continually working throughout the year. So if we start on the top left, we're now in January starting to prepare for our spring peak meeting, the preview of ecosystem and economic conditions. We'll hold that in May. We'll start to have our first look into what's happening in the ecosystems, whether it's from satellite data that's collected all the time over the winter, or some of our spring surveys. Maybe some of our winter fisheries are providing some information. And we encourage community members. Gay has participated in that meeting, and the map agents for the last number of years, to give us the what's the word in your region, what's happening, what are the topics of interest. And then we start to go through our science and sort of research stock assessment process. We start to ask for contributions to the ecosystem reports. Surveys start to go out and collect information. And then we start through the plan team and council process. September, October, November, December gets pretty busy, lots of those different meetings. And then finally in December for groundfish, those final quotas are set. So I'll now go into the 2023 ecosystem status report. This slide has all of the contributors. So on the left-hand side are the different agency icons of folks who contributed to the report, and on the right, the individual names of all of the people who contributed. The Bering Sea is fortunate in that it has this wealth of information. I said earlier, there are a lot of people working in the region and willing to then contribute their expertise and their data to the ecosystem status report, so that it goes straight to the hands of the deciders, of decision makers about fisheries quotas. I think there's about maybe 110, 112 people who contributed this year. So it's a lot of information. And I will say, just a couple of years ago, maybe the report was sort of 50-50 information from the year prior versus information in the current year. And because the decision makers really want the current information, they want to know what's happening, that message got back. Researchers are really making an effort to give us real-time information. So you'll see today, I think everything like 95 or more % of the report is 2023 information. And that is because of the willingness of our contributors to share that information. So we always like to leave this slide up for a couple extra minutes. So because we're so grateful to everyone who contributes. Okay, so we'll talk about the 2023 ecosystem assessment. We divide the Eastern Bering Sea, which is the shaded area on the map there, into the Northern and the Southeastern Bering Sea at 60 degrees north. And there's, won't go into it now, but a variety of reasons for that, both oceanographically based on where currents are going, and biologically differences in bottom habitat and distributions of fish, sea ice dynamics, cold pool, all of that came into this decision to split at 60. So later in the talk, if you see things labeled as Northern or Southeastern, that division is at 60 degrees north. So for 2023, the kind of take-home message that I tried to get across through the council and to the managers and decision makers is that the Bering Sea has cooled. There was this excitement that we had sort of average sea ice extent last winter, and it has cooled, but it is not cool. it is still warmer than this long time series average. So this goes back to 1985. The black horizontal dashed line is that long time series average, and then plus or minus a standard deviation are the red horizontal lines. And so you can see people know like 2018 and 19, those two really warm years with really low sea ice. They can't see me, can they?
No, your cursor.
Oh, I can do this one. Okay, 18 and 19, right? Those were really warm years, really low sea ice. So it has cooled compared to those warm years, but we are still above average. We look at sea ice, it's such an important driver of almost everything else happening in the ecosystem. And there's a couple of reasons I wanted to talk through why it's so important and why we track it from a sort of ecosystem standpoint. One is that it changes the vertical structure of the water column. So in the Northern Bering Sea, where we are in Nome, as sea ice is forming, the salts of the sea ice are being extruded, and regionally up in the north, you see this increase in salinity of the water. As that sea ice moves down over the shelf, like this conveyor belt comes down over the shelf, at the southern extent in the spring, when that ice melts, it's fresh water that is released into the surface waters, and this, in a local sort of sense, decreased salinity. So the little cartoon icon in the middle is supposed to just sort of depict why that matters. It matters to where things are in the water column as food. So seabirds, if it's highly stratified, things might be sort of trapped in the upper part of the water column. That could be good for seabirds. Shallow water diving seabirds can get to that food. It might not be as good for some kinds of pelagic fish if they're, in a sense, sort of separated from food vertically. Even though they might be in the same space, we thought about it horizontally, they're separated vertically, and that's important. The other thing we track is what we call the cold pool. It is sort of a footprint of where sea ice was the previous winter. So this data is from a regional ocean modeling system. A very similar plot comes out of the Race Bottom Trawl survey that shows where the cold bottom water is. And that cold bottom water, we define it as less than 2 degrees Celsius, sort of determines whether fish are interacting with other fish, and sort of this thermal barrier to whether they can move up or down, north or south over the shelf. So it again becomes a pretty important characteristic of the whole ecosystem. There's someone else in the waiting room. I can see.
Absorbed in your talk. It's good.
So I know Rick is online. Thank you. Rick is instrumental in providing these great graphics of sea ice and helping me think about what it means for the ecosystem. So this is a plot that he puts together sort of continually through the winter. This is a capture of last winter, 22-23, the development of the sea ice in the fall and the melting of it in the spring. And it is in the ecosystem report. And one thing, so it starts in November here on the bottom left, this sort of slow startup to sea ice last winter, that has been sort of a common feature as it's been warming in the last few years, or has been warm in the last few years. It takes longer for the whole system to cool down and be able to form ice. So that delay of sea ice has been not uncommon, but even relative to that last winter, compared to the winter before, 21-22, this green line, about a month later. And partially that is also an impact of Typhoon Merbach coming through, stirring up the water column, keeping things warmer, surface top to bottom, and just sort of delaying when sea ice could form. Once it started, it did pretty good last winter, came up, this dark black line in the background is the median over since 1991 to 2020. And it bounced around. That bouncing around happens as winds are changing, either from the north or from the south, blowing ice down or blowing the ice out. And then, if you lived here, you had a really cold spring, And so that melts out last spring, especially compared to the year before later, closer to the time series average, but later than the year before. So I'll talk through the southeastern Bering Sea, what it looked like in 2023, and then we'll move to the Northern Bering Sea. And kind of the same structure of slides. First, we'll talk about the base of the food web, and then we'll move up from there. So in the southeastern Bering Sea, the base of the food web we look at by looking at things like chlorophyll A. This is green algae. We can measure it from satellites, and it's given to us. Jens Nielsen and others provide this based on satellites. They split it out into the 8 regions in the map in the lower left. So the boxes in the figure, I need to stop pointing to the screen, sorry. So this is the off-shelf region. Here's the south outer, south middle, and south inner. That's these 4 regions down here in the map. And so that chlorophyll A, the algae, the bottom of the food chain, has had, you see this sort of long-term decline over the last 10 years or so. And in 2023, it being the lowest value in many of the different subregions. With that, we also had, again, satellite-derived coccolithophores, which are a type of phytoplankton, but not thought of as being a good food source or a good phytoplankton. They have these sort of hard calcareous shells. They're small. They lead to sort of longer trophic chains, so less efficient transfer of the energy. So while we didn't have maybe what we would think of as like the good food, we had a lot of these coccolithophores not thought of as a great food source. And that index provided to the report was the highest in the time series, going back from 1997 to 2023. And this satellite image, if you'll believe me, under the clouds here, the Alaska Peninsula, Bristol Bay, and up to, Nome is probably just at the top left there of the map. But in the background, under the clouds, you can see this sort of milky color to the ocean. And that is the coccolithophores. They cause this milky color, and it can be difficult then for visual predators, seabirds or other forage fish that are looking to find their prey. It can be harder to find it in those conditions as well. So another sort of challenge to the food out there. Okay, we also have several different surveys that go out and measure the sort of the zooplankton. So we have the phytoplankton base of the food chain. They're being eaten by zooplankton, copepods, and things like krill, jellyfishes. And so we track these both. We have spring surveys and fall surveys that track over the southern Bering Sea. And last year in the spring, there were moderate abundances of small copepods, but low abundances and low quality, like fat content, of the large copepods and krill. And that isn't necessarily bad news. In the spring, the fish too, like they're smaller, they have smaller mouths. So having small copepods available as a food source is a good thing at that time of the year. What they need, the fish need there to be, are the large copepods by the fall survey, so that they can fatten up and survive that first winter. And so from our fall survey, this middle plot here, I'm just showing an example of large copepods. We did still have small copepods, but the large copepods remained pretty low over the southern shelf. So not a lot of those big fat copepods that the fish need. Though we did see they went from very low, and in some cases 0, up to higher abundances at the northern end of that survey, sort of where the ice edge would have been. So good sign, sort of moving north, but low over the southern shelf. And jellyfish, this is data from the bottom trawl survey again, were sort of average in 2023, and they are also out there eating the copepods and the krill. So they're sort of a competitor to fish in terms of being able to eat what's out there. Okay, this next slide has lots of different graphs, but it's sort of looking at everything that's out there in the water column, eating the zooplankton, and how are they doing. And so there's in the top left, age 0 pollock. They're out in the water column. They need the zooplankton. In the bottom left are juvenile salmon species, also out there needing the zooplankton. In the top center are togiak, herring. In the middle, adult pollock. And in the bottom right, this is data from the Fish and Wildlife Alaska Maritime Refuge seabirds, also out there as indicators of how that pelagic water system is doing in terms of productivity. So many of these different metrics that I look at to kind of say, take a step back, how is the pelagic ecosystem doing? There were some mixed, some things are up, some things are down, but largely things were down over the southern shelf. So age 0 pollock, their condition has been below average since 2014, since we went into this sort of stanza of warmer years. And even though it cooled for 2022, 2023, we haven't seen the fish condition come back like we would think under cooler conditions. For the juvenile salmon, I know you can't read that from top to bottom, pink salmon, chum salmon, sockeye, coho, and Chinook salmon, all of their conditions also below average over the southern shelf. From the bottom trawl survey in the center here, this is juvenile, sort of age 2, maybe 3 pollock. Their condition has been declining in the last few years. Adult pollock also declining in the last few years, but not everything. So not togiak herring have had a couple strong year classes, 2016 and 17, even though in this warm phase did well, and their biomass is sort of remained high because of those strong year classes in 2016 and 17. I'm not showing the Bristol Bay sockeye salmon, but similar story. They've had high returns for Bristol Bay sockeye since 2015. Their biomass has done well. So there's sort of some species doing well, others not doing as well, kind of mixed in the pelagic. If we go to look at the seafloor bottom, who's living on the bottom and how are they doing? Also mixed over the southern shelf, but largely again showing declines. So on the left, data from the bottom trawl survey, some things are doing okay. Sea anemones, sea whips, sponges declining. Those are habitat for other things on the bottom.
You got a mouse.
Oh, sorry.
Yeah.
Keep pointing,
Yeah,
sorry.
it's okay.
And then this top figure here, this is tracking groups of organisms. So this top one says motile epifauna. Those are things moving that live on the seafloor. So sea stars, brittle stars, a bunch of different echinoderms, but also your crab species. They're all grouped together in this guild, and they've reached a peak in 2017. They've been slowly declining and just above average in 2023. And you think to yourself, but I've heard the stories about crab, all of the stocks that have declined. How is that as a guild still at average? And it's because the brittle stars and the sea stars are maintaining that biomass. So we have this continued increase in sea stars and brittle stars, even though this decline in the crab stocks. The second ticker tape there, the benthic foragers, those are your flatfishes, your bottom yellowfin sole or arrowtooth flounder. They have been down for the last 2 years and are even below the 1 standard deviation of that time series average. So those are bottom fish that depend on getting food on the benthos and not doing as well. Another sort of way to look at that is to look at the fish condition of those flatfishes. So this is again from the bottom trawl survey, yellowfin sole, Alaska plaice, arrowtooth flounder, and flathead sole. All of those fish conditions declined from 2022 to 2023. Several of them are close to their time series average, but as a whole declined from 2022. And then the bottom ticker tapes are I'm showing examples from snow crab, again, just to reiterate the declines in several of the different crab stocks over the last few years, including 2023. So then I'll go over the Northern Bering Sea in that same framework. I'll start with the base of the food chain and go up. And I think the take-home messages you'll see, the Northern Bering Sea has also cooled, and it seems like some of the biological things, the zooplankton and the fish condition, have done better or maybe rebounded faster than the Southern Bering Sea for the kinds of time series that we had to look at. So here's the base of the food chain, primary productivity from the chlorophyll A on the top. This is still down, right? In every region, Bering Strait, North Outer, North Middle, and North Inner Shelf. Same declines that we saw over the sort of 10 years in the Southern Shelf, and 2023 being really low levels. But for the zooplankton in the lower left, this is from a surface trawl survey that Jim Murphy leads. So you'll have that straight science in a couple weeks. So not to give away all of his story, hopefully, but they showed some good abundances and some hot spots of these large copepods and the krill. This is a late summer survey around St. Lawrence and in the Northern Bering Sea. So that's good food at the right time when the fish need it in the region.
And just quickly, can you describe what a hot spot is?
Just a good high number in an area. Yeah.
Thank you.
Yeah. And also from that same survey, they provide a metric of jellyfish similar to the Southern Bering Sea. And so this is just showing an uptick from 22 to 23 in jellyfish as well. So again, these are competitors. These are other things out in the water that are eating those large copepods and krill. But some good, I thought that was a sort of a good sign for the zooplankton. Okay, looking in the pelagic environment, we don't have as many data streams and metrics from the Northern Bering Sea, but these are in the top left. Now, as you know, the Bottom Trawl Survey has added their Northern Bering Sea extension now for a number of years since 2010 and through 2023. So they can now provide time series from just that northern extension of the Bottom Trawl Survey. And for adult pollock, their condition has been increasing the last few years in the Northern Bering Sea. Pacific cod as well, it's been increasing. It's just to their time series average now, but increasing since this low point of 2021. But the juvenile pollock in the Northern Bering Sea, sort of opposite of the Southern, they've been, or similar to the Southern, I should say, declining there too, just below the time series average in the Northern Bering Sea.
You do have a question in the chat, and I'm not sure if, because I don't know what the question is from Stacy Lucason. Are these all from within the NBSCRA? And I don't know if that means something to you because I don't know what that means. It is not clear on the map what is meant by the Northern Bering Sea. Oh, I think check me if I'm wrong. Oh, thank you. Northern Bering Sea Climate Resilience Area. My understanding is, just from watching this, Stacy, is the Northern Bering Sea cutoff is 60 degrees north. Is that right?
That's the southern, yeah. So from 60 degrees north to the Bering Strait is the Northern Bering Sea.
And we can go over that in when we're done. But thank you for putting out what is the NBSCRA. Appreciate that.
Yeah, thank you. And it probably any of these particular graphs I'm showing would be from the spatial extent of a particular survey. So that could change. Holistically, we're looking at what it tells us about that whole Northern Bering Sea area. So in the Northern Bering Sea, 60 only in US waters. Yes, Rick, because our surveys are, yes, we just have information from surveys in the US side of the Northern Bering. Yeah. So in the center there, juvenile salmon energy densities, again, from that Northern Bering Sea surface trawl survey that the zooplankton data was from. For this, the data are only updated through 2022. So 21 and 22 I've highlighted here because this is when it was a little bit, it's been cooler in the Bering Sea in these 2 years. So again, for pink, chum, sockeye, coho, and chinook, all of those species in the Northern Bering Sea, their condition, their energy densities are above average. So a good sign for the juvenile salmon in the Northern Bering Sea at a time when we know that those runs have been struggling. In the bottom left here is from also the juvenile, that surface trawl survey from Jim Murphy and others at the Auke Bay Labs, looking at the CPUE in the fall of chum salmon in the Northern Bering Sea, and this slight uptick here from 22 to 23. So we're seeing both the slight increase in abundance and an increase in their condition in the Northern Bering Sea. So the next couple of slides, I want to talk about this contribution that was a collaborative effort to look at all of the different factors affecting the 2023 Yukon and Kuskokwim chum salmon runs and subsistence harvests. And this was a contribution put together by several, Kevin Whitworth and Teresa Vicente at the Kuskokwim River Intertribal Fish Commission, as well as Katie Howard at the Alaska Department of Fish and Game, and Vanessa Von Vila at USGS, and then Megan Williams and Patty Chambers at Ocean Conservancy. I hope I got all of that right. But the idea was to look at the 2023 in a way to try to explain why are we seeing these big, really collapses of salmon runs in Yukon and Kuskokwim when Bristol Bay sockeye has been doing so well. And so the idea was they sort of rolled the clock back. So let's roll back to the parent spawners of those 2023 returns. And what are the conditions that those fish have encountered in their lifetime that might explain why we aren't seeing them return in 2023? So I know you can't read anything on there. The full report, if you want to, I can at the end give the link to the full report and you can dive into these. But what I wanted to do and what I did for the council was to sort of zoom in on a couple of these different boxes around the outside, because what I wanted to use this as a demonstration. The council often is asking us to include local and traditional knowledge, and this was an example of a way where traditional knowledge was provided and to help them think about how they might be able to use that in their decision making. So the first box I'll zoom in on here is from the other graphic, box B, looking at those marine juveniles. So these are fish that are coming out of the rivers into the Bering Sea and then overwintering in the Gulf of Alaska between 2019 and 2021. The Western science from ADF&G and from USGS is in the box. There's a graph from Jim Murphy's results from that Northern Bering Sea surface trawl survey, looking at the stomach fullness of those fish in 2019. Sorry, I was going to point at the screen again. So here's 2019. It's the warmest water and the lowest stomach fullness. So these fish are not finding a lot to eat in 2019. And so there's, from this sort of Western science perspective, this data time series, a look to say, here's maybe one reason. Here's one sort of challenge they faced in that it was warm and there wasn't a lot of food. And then Kuskokwim River Intertribal Fish Commission provided this quote from one of their members. There's the climate change part, there's bycatch and things like that. And then not only the ocean life, but also what's happening in our spawning rivers, the health of those because of climate change, too much snow, not enough snow, too cold, too warm, how different everything is changing. I think there's a lot of things that come into play. And so one of the things I wanted to highlight to the council was, we have to remember that what's happening when we go to sample in the Northern Bering Sea includes what's happening in the rivers, right? So the Bering Sea ecosystem, if we look at it, doesn't end at the coastline. It goes far inland because it's impacted by all of the conditions that these fish are encountering in the rivers as well. And so just that the traditional knowledge can help inform some of everything that's happening. The second box I'll highlight is the maturing adults in 2023. And again, the top graph I showed earlier from the surface trawl survey, this uptick from 22 to 23, also reflected in the in-river run sizes, this uptick from 22 to 23. And then the traditional knowledge quote from Kuskokwim provided, there are more chums in the river in 2023 and people were catching more. But when compared to the past 40 years and even just 10 years ago, there were far less chums in the river running and being caught by the people now. We should not pretend that this season's slight increase means the chum run has significantly improved. And again, one of the things I wanted to highlight to the council about how to use this kind of information is to say, you know, if we look at the time series, the surface trawl survey starts in 2003. So we've got maybe 20 years of information we can glean there. The in-river starts in 1992. This traditional knowledge is saying even 40 years. So we can provide that longer time horizon for the context of what we're seeing now as a way to help us ground what we see now compared to what was observed for a much longer time scale than just our survey information can give us. Okay, and then I think this is maybe my last slide from the ecosystem assessment. We do have just a few sources to look at what the seafloor and bottom habitat is looking like in the Northern Bering Sea. So on the left, I'm sorry that all the fonts are so tiny on these these graphs, but they were brand new this year. The bottom trawl survey with that northern extension finally willing to provide, feeling like there was enough data to put it in a sort of time series plot. So we'll work on making them bigger fonts next year. But in the top left, anemones, maybe declining, sponges declining, poachers declining, eel pouts have been low and continue to be low in the Northern Bering Sea. And then some of the flatfishes in the Northern Bering Sea, yellowfin sole has declined to their sort of time series low in 2023, and Alaska placed just below their time series mean for the last 3 years. So the in terms of the bottom habitat, not as good of signs as we maybe saw in the pelagic for the zooplankton and some of the fish condition metrics. Okay, so just 2 slides on risk tables. How do we use, we have all of this information, we're so fortunate. How do we use it? How do we help the managers know how to use it? And one of the ways is we have these risk tables, and every fall, the ecosystem leads meet individually with each of the stock assessment authors. So I put Pollock in the middle here just as an example. Jimmy and Ellie is the stock assessment author. I sit down with them and I say, here's all of this information that we got from 110 experts. Here's what I think it means in these different contexts. How do I think the environmental conditions are for pollock? How do I think the prey conditions are for pollock, competitors and predators? And then I make a recommendation to him whether I think there's enough concern that he should recommend reducing that maximum acceptable biological catch out of his stock assessment model. Do we think we should maybe reduce a lower number? And so for 2023, we did risk tables for these 6 stocks. So pollock, yellowfin sole, Pacific cod, sablefish, which is managed as Alaska-wide, skates, and octopus. And you can see at the top for pollock and for yellowfin sole, in terms of the ecosystem conditions, I recommended a level 2. And the justification there, I won't read them all, but we've gone over it today in terms of whether we think there isn't good food source out there, or the condition of, you know, for yellowfin sole, for example, many of the flatfishes were all showing skinnier condition. And at the council, as an example for pollock, the stock assessment author, Jimmy and Ellie, did recommend a reduction from that max ABC and did cite these reasons in terms of the productivity and the declining trends in the juvenile and adult fish condition. And that was accepted by the council this year for 2024 quotas.
How many levels are there?
So there are three. I paused for a minute. There used to be four, and we were asked to make it three. So there's level one is that we don't think there's any concern that isn't, and I should say our management system and the stock assessment system already has built into it conservative measures. So this is just additional concern that isn't already captured in how we manage our stocks. So one would be no increased concern, two is an increased concern, and then three is, I forget exactly the adjective, extreme concern or something. And the definitions of how you get to a 2 or a 3 have to do with whether do you only have concerns in terms of what we call bottom up, so like food source concerns, or 3 might be we have food source concerns and you're getting hammered by a lot of predators. So if you're sort of getting squeezed from both sides, might get a level 3. Okay, so just a couple slides on where we're headed. This is a figure from Nick Bond on the developing El Nino, which is a feature along the central equatorial Pacific. For the Bering Sea, just El Nino alone isn't really the determinant of the weather patterns we'll see in the Bering Sea, but it's a factor we look at, and for the Gulf of Alaska, it can be a little bit more important for how we see. I'm from Juneau, the weather we've had in Juneau, pretty typical of an El Nino winter, but for the Bering Sea also depends on our more local wind patterns and the Aleutian low pressure system in our region. But so I have just a couple slides, and thank you again, Rick, for these great graphics. When I presented the ecosystem status report to the council the first week in December, this is where sea ice was. And we were thinking El Nino and really warm conditions and really concerned for what the sea ice was going to be. Where would the cold pool be this upcoming year? So this is sort of where we were. But December cooled off, winds came from the north, sea ice was able to form. From a sort of satellite perspective, the aerial extent, at least, of sea ice by the end of December was not atypical, but the thickness of it was pretty thin and sort of vulnerable to changes in the winds. And so I think Rick today just gave me a couple more slides I'll show for what's happened just in the last week or so. So here's this slow start to the sea ice in November. And then last week, it's falling out and some reduction of sea ice over the and then a picture zoomed in of that ice concentration from yesterday, showing some areas like here in Norton Sound, open water, here on the north side of St. Lawrence, open Kotzebue Sound. So it's very mobile and changing fast right now, but interesting to see what will come in the next week as the winds change back around. So again, I put this slide back on because I hope that this audience, I just want to highlight again where we're headed in 2024, will be interested in May to hear what people are seeing in the region and in terms of conditions, and what you think we might want to be paying attention to as we go into the 2024 management cycle, to know what's important. So with that, these are just contacts. The QR code will get you to the website that has all of our ecosystem status reports for the past. And I'll just shout out to my ecosystem status report colleagues here. Bridget Ferris leads a comparable report to this for the Gulf of Alaska. Yvonne Ortiz leads a report for the Aleutian Islands, and Stephanie Zauderer was one of the original ecosystem reports, and now helps sort of across the board with all of our reports. So thank you.
All right. So before we get to the questions, and we have questions from you.
Don't unmute.
I'm not muted.
No, mute.
I am muted. Oh, wait.
Thanks everybody for that, and thank you, Ebett. She knows her Zoom, but I can't hear anything. So, all right, so we have questions from Stacy in the chat box, but before we get in there, I want to say thank you to Ebett. That was really great, and honestly, you have such a polite way of for the Southern Bering Sea. It didn't look like good news to me, but you were very nice to deliver it so well. But that's just me. And this is the time for people in the Strait Science audience to put a little love for our Strait Science speaker tonight in the chat box. It is never easy to be a public speaker, speaking personally, and for just about anybody else who has to public speak. It's never easy to get up and have to say your bit. So thank you so much for Ebett's presentation and for the Strait Science audience showing a little love in the chat. Now, that should give people time for questions, and we've got Stacy has some questions to lead us off. And I put the link into the report as well.
Oh, thank you.
The question is all this, and I think for this, is this Northern Bering Sea or is this for the whole thing? Is all the seafloor survey work done with trawl equipment? That's the first one. I keep hearing that bottom trawling is not allowed in the protected areas. And I can actually help with some of that areas. I have a question on that. Can you share more about the methodology here and what's different in this work than trawling that is prohibited?
Sure. So the new metrics that I showed just in that all the fonts you can't read on those new graphs, those are data from the NOAA bottom trawl survey. That is the extension of their standard bottom trawl survey for, it is the main survey where we get all of the biomass of our fish stocks in order to run the assessment models. So as stocks have shifted north and south over the shelf, that survey has needed to also extend north in order to sort of accurately capture how the fish stocks are doing. And so it's from that survey that they provide these other, anemones, sea whips, sponges that they're also collecting while they're doing the bottom trawl survey, if that helps.
And then I don't know, because thank you, Stacy, for that acronym, the Northern Bering Sea Resilience Area, because, and I may be outdated here in so many ways, but there was, to me, when I was looking at, this was a long time ago, looking at what areas are critical habitat in the Bering Strait region, what are the rules, there was, I have a little cheat sheet, and one is the Northern Bering Sea Research Area, which is a bigger area that goes down to this pretty far south of St. Lawrence Island. And I had that as the entire Northern Bering Sea research area will be closed to bottom trawling while a research plan is developed. So that's called the Northern Bering Sea Research Area. And then I had another, and if you look these up, you should find the maps, and I hope they're still in play. I don't know, so forgive me if I'm out here. But the other is the St. Lawrence Island Habitat Conservation Area. And those are there's three habitat conservation areas. One is around St. Matthew Island, one is around St. Lawrence Island, and one is an area encompassing Nunivak Island, Evelyn Strait, Kuskokwim Bay. So I hope those help. If those are still in play, I'm unsure, but those were kind of the go-to areas regarding. And then there's critical habitat that I'm aware of in the Bering Strait region at Punuk Island, which is southeast. It's an island complex southeast of St. Lawrence Island, and then at Southwest Cape on St. Lawrence Island, and that's for stellar sea lion haulouts. So I hope that helps add to the mix. And then Stacy also asks, appreciate the contact info. Is the Northern Bering Sea with the Eastern and you, Ebett? I'm not quite sure.
Bering Sea.
Stacy, for your question, maybe you can unmute. For the appreciate the contact info, is the Northern Bering Sea with the Eastern? Do you mean that that map of everything? Because I actually got confused when Ebett started. She had to tell me on the side a little bit before we started. I saw her slides and I was like, I didn't know. I thought we are so used to the NOAA race division telling us what's the Northern Bering Sea, but they have their own different definition of Northern Bering Sea, and that's that 60-degree cutoff at US waters. So that was new to me, actually. Is that what you're asking?
Yeah.
Okay.
Yes. So yes,
Okay.
Stacy,
Okay.
in terms of, because these reports were developed really as a management document for the council. They're very sort of focused on what the fisheries management area, the management areas are. And so for the Bering Sea and some stocks are managed Bering Sea and Aleutian Islands. We've separated Aleutians in terms of the ecosystem reports, but the Eastern Bering Sea ecosystem status report includes both the southeastern and the northern, the Northern Bering Sea. Hopefully that answers your question.
Yeah, let us know if you have any other question on that, Stacy, or feel free to unmute. Rick Tolman has his hand up. Go ahead, Rick.
Thanks, Ebett. Great overview. Boy, a lot of material. It's a fine job there. Thank you. I guess my question is, and this is one maybe that you don't know, maybe nobody knows. As you pointed out, one of the big changes in recent decades in the Bering Sea is the much later ice formation. That we lost a lot. The ice is just forming later, which means by the time we get to January 17th, the ice has been growing for a month or more or less than it had been back in the day. And so we've seen I think some impacts of that, like in 2020, what was it, 2022, when the ice briefly got to St. George in the Pribilofs, but at the exact same time, the ice was in terrible shape in the Northern Bering Sea. And so I'm wondering, from the sciencey, physical science side, if you know, is there a difference in the brine expulsion between thin ice and the historically more typical ice thickness, which then presumably also impacts what's going on through the water column and in the cold pool as well. So thanks.
Yeah, I mean, great question, Rick. And I'll add in there to your question that I might not have an answer for. What is the impact to ice algae? You know, if the ice residency is shorter, do we get less ice algae? What is that loss to the overall primary productivity of the system? I don't know that we know, and I am sort of guilty of. I continue to hammer on this idea that as we build and melt ice differently, it impacts that vertical stratification. And I've been told by physical oceanographers that change in salinity isn't a lot, and I'll continue to sort of question it, because I think slight changes in salinity could have big changes in terms of density and biological impacts in terms of where things are and where food then is available to other things in the system. But we just don't know. I don't have an answer, except I'm asking the same questions you are. And I'm glad we're asking it in this audience in case somebody has an idea of who could sort of help us think about it. And you and I have talked about, should we be looking at ice volume? Could we start to use that time series and correlate with productivity or other outcomes in the system? But I don't know.
And I'll just add, it would be nice, this came up in a conversation, I think this morning, a different meeting, is there an ability to calculate kind of sort of what you're getting at? Like, what if you have sea ice for only a month under certain conditions, how much of a cold pool can you expect? Can you model what the cold pool will be based on extent, duration, and quality or thickness of the ice, and come up with a sort of just what you're asking, like a formula on, well, here's what we've got, and these are the parameters for that, and this is our best guess on the cold pool. But I don't see that. I don't know how to do it, certainly. And I'm just wondering if that's something, certainly seems like it would be terribly useful to use as a predictor. But thank you for bringing that up. That's a great question.
So if I could just follow up on your comment there, Gabe. So, and Ebett knows probably more of the details, some of the modeling effort to model, and I think you showed an image there early in your presentation on the modeled bottom temperatures. And I think it was on Strait Science maybe a year or two ago about that. At least at that point, the model seemed to be doing pretty well with bottom temperatures that were modeled and then compared to what the observations were from the race survey, like north of St. Matthew Island, but southeast of there, where the ice is more, it comes and goes during the course of the year, that the model did not do so well. I mean, it maybe was in the ballpark, but definitely was not in the right section. And my concern, I guess, is that, as we move forward in time and the ice is thinner in the Northern Bering Sea, it comes and goes. It will be coming and going more than it used to, that we could get into that kind of situation where that ice thickness starts to matter for these other things. It's not just a binary yes or no, there's ice.
Yeah,
Anyway,
you're exactly.
thank you.
You're remembering that correctly, Rick. They thought they had this ability to forecast. It was like a 9-month forecast of cold pool, so they could do it the fall before for what they thought would be the summer. And what they learned was the winter, what's happening in the winter with changes in winds and whatnot. They are not able to quite model and predict. So now, like the modelers, Kelly Carney and others, they will present at the spring peak meeting in May a forecast for the summer cold pool. That modeling is good, like a 3-month sort of lead time modeling. They are able to do with great skill and ability. They just can't get it over the winter right now.
Okay, thanks.
All right. I have a question, if there's no others running away here. And that is, so for the southeastern Bering Sea, there are, of course, more, NOAA's had a longer term relationship with those surveys and with the commercial fishing fleets and all those sorts of things. For the Northern Bering Sea, you said there's a lack of and rightly so, right? We don't have the big commercial fishing and all that. We have our own little commercial fishing here, but it's not like the big fleets that NOAA is used to dealing with. But we also have co-management. And I wonder, I was looking at it came to me when I saw all your logos. We have the co-management for ice seals, walrus. I don't know if the sea lion one is operational. Certainly beluga is operational. Those are co-management and migratory birds. So the seabirds, waterfowl, things like that. Those might be a great way if there, I couldn't remember if I saw the waterfowl logos and stuff, but those might want to be, I don't know if they've been approached as ways to get information that might be extremely helpful for the marine mammals, for seabirds and things like that as a way to go, because they're not comprehensively representative of our region. Not every single tribe can be in the Eskimo Walrus Commission or be in the Alaska Whaling Commission. And actually, I would say even the Alaska Eskimo Whaling Commission has four of the communities that make up the Alaska Eskimo Whaling Commission are from this region. And so that might be a way where you have a federal nexus and a tribal representative, partnership right there. I would add those to your list. I don't know how people get on that list. You're always nice to have the Sea Grant people on, but I would
for
add
Spring Peak or
all of it,
Yeah,
because I think you would get more than maybe one researcher who's doing birds. You might actually have, I know we have just for the Bering Strait region, and I'm probably going to speak out of turn. So if anyone's from Kawarak and knows we have our own Bering Strait, Norton Sound, I want to say Migratory Bird Council, and then that feeds into the Alaska Migratory Bird Co-Management Council. And so we have multiple sort of layers of communication that would be maybe more comprehensive, and you'd want to add that. So.
Well, and to sort of answer that, and I see Stacy's other question in the chat. Yes, Stacy, these reports were developed primarily for the Management Council to help give that contextual information about the ecosystem for the ecosystem-based fisheries management. We've recognized certainly there's a lot of other uses of the report. We often hear from other researchers like, oh, I went back and I, referenced your report, and this sort of like community engagement, K through 12 schools, right? There's lots of ways that we use the reports because they're such a wealth of information because of the contributors. But in some ways we have to sort of remember that they are geared primarily to that council use. And so, yes, I wrote down co-management as an avenue. We're constantly looking, these reports are not a turn the crank every year. We're continually looking for new sources of information, iteratively, like thinking about what captures the ecosystem in these different ways. So we're always interested in whether there's another knowledge source out there to help us. But through that lens of the fisheries management primarily.
And I would just add, because I'm old, the NOAA race division was unknown to this region. They did their very first survey in the Northern Bering Sea, so north of 60 degrees. I can say that now. They only did that in 2010. And the NOAA, probably these ecosystem reports have been going on for the Southern Bering Sea, since you guys have been every year since 1970.
30th year.
Yeah, they're on their 30th year for the Southeastern Bering Sea.
Before all ecosystem status reports.
Okay.
Sorry. Yeah.
And then just for us up here, 2010 was the first time they even came and did a survey, and then they disappeared again for another 7 years. And the second time they ever came up, and I mean in the NOAA race division, was 2017, when everything was starting to fall apart because of the heat we were getting.
But we have had others, so there are other NOAA surveys that have been in the region. So like Jim Murphy's Surface Troll Survey has been every year since 2000,
That's helpful.
early 2000s, can't remember the exact year.
Yeah, but it's not like, I think the Southeastern Bering Sea's been going on since the 70s.
82.
82. All right, so they've got kind of a big jump on dealing with the Northern Bering Sea. So I hope that helps everyone. It isn't like that big picture in the beginning when you have it. It's not like that's been comprehensively done since day one. I don't think anyone figured they were coming north as quick as they had to, because of the conditions have made it so that now they need to get up here because things are changing so fast. that helps everyone, I don't know. But thank you. Oh, is that you got that last question there?
Yes, I
Okay.
think so, yeah.
Any other questions? We have callers, and I'm so sorry. I apologize to the callers. We did not unmute. If you have a question, or you can call or text my cell phone at 907-434-1149. Megan, I see you on. Do you have any questions from your end of things? We'd want to make sure those get answered. Megan Gannett. Right, no questions from Megan. With that, no question in the audience? No question. All right, well, with that, thank you everyone so much. The next Strait Science, we're going to take a little break until February 1, and the next one's going to be a little different. It's going to be about some of the equipment, hydroponics in Western Alaska is really what it's going to be. And we're going to hear from one of the engineers that actually put together some of the heat pumps and how they figured out how to be able to do hydroponics in Western Alaska, in Kotzebue, and ostensibly you could do it in this region 12 months of the year throughout the winter in a connex, and how they were able to do that. So with that will be February 1st. And thank you so much, Ebett, again, and have a good night, everyone. We'll see you next time.